start with the trig today. This is a Ferris wheel. And you are on this cart right here, the little green one. Now, the Ferris wheel, there are 30 cars, and it moves one full rotation in 30 minutes. So you can pretty much figure out that every minute it's going to move one car length. So if you start here, 1 minute from now, you're going to be here. A minute from then, you'll be here, and so forth until you complete the entire revolution. Now, we're going to assume that you're going to start at the base of this Ferris wheel, and the height of this Ferris wheel reaches a maximum height of 130 meters. Now, my question to you is, if you can try, and I want you to bring this to class, what you feel the graph of the height, or of your height, will be during one full rotation, starting from 0 all the way around and back to 0. In other words, you are going to graph your height from the platform of the Ferris wheel for one full revolution. And what do you think that might look like? So do me a favor, stop the video now for a minute, try to figure out what that graph might look like, and write it down on your paper. Okay, we're going to continue. The Ferris wheel problem we'll talk about when we're in class. Now, in this problem, we have what we call a unit circle. I think we talked about the unit circle last year, but if we didn't, we're going to talk about it now. What is a unit circle? A unit circle is a circle with a radius of 1 unit. It could be 1 inch, 1 meter, 1 foot. But we're just going to talk about 1 unit. So point A, being on the x-axis, will have coordinates 1, 0. Now, all of these have a radius of 1. So, what will the coordinates of point B be? Now, I know that the height of B from my x-axis all the way down, or if you will, what my y value for point B is, I'm going to call that my y value, my distance from the x-axis to point B. What will that be for an angle of 45 degrees? Well, since this is a right triangle, we can use, remember, we talked about it in class, whenever you have a right triangle and you want to find the sides or the angles, you're either going to use SOHCAHTOA or you're going to use Pythagorean theorem. Since I don't know the length or the x value here, I'm going to try to figure out what this is using SOHCAHTOA. This is 45. In relationship to this angle, y is my opposite side, and 1 is my hypotenuse. Now, knowing what we know from trig from last year, what ratio uses opposite and hypotenuse? If you said sine, you'd be right. Remember? SOHCAHTOA. Opposite and hypotenuse would be sine. So the height would be, or my y value, would be the sine of, where can I put that? Let's put it up here. The sine of 45 would be equal to y opposite over my hypotenuse, which is 1. Now, obviously, what is y over 1? Y over 1 is just y, so the y coordinate here, my height, is going to be the sine of 45. Whatever that angle is, my height will be the sine of this angle. Correspondingly, over here, my x value, if I'm talking about this x value, and I still want to use SOHCAHTOA to find out what my x value is, in relationship to 45, this is my adjacent side, and this is my hypotenuse, and we're trying to find adjacent, we use cosine. So the cosine of 45 is equal to x over 1, and obviously x over 1 is just x. So therefore, x, my x value here, is going to be the cosine of 45. Does that make sense? Now, this angle here formed from here to here is in standard position. In other words, its terminal side starts at 0 and it's going to move counterclockwise around the circle. So, if I were to go from the terminal side, from 0, and go all the way around to here, how many degrees would that be? Well, I'm 45 degrees away from 180, so if I say 180 minus 45, I should get 135. So this angle here has a measure of 135. So, if I wanted to find the x-coordinate for 135, it would be the cosine of 135 and the sine of 135. Now you're going to notice one thing in common. Because they both have the same height, the sine of 45 is going to be equal to the sine of 135. Does that make sense? I hope it does. However, because the x value from here to here, it is the same distance but in the opposite direction, the cosine of 45 is going to be equal to the negative of the cosine of 135. If you think about it, whatever this is here, whatever value this is going to be the same value in the negative direction. If I were to continue going in the circle all the way down to here, where this side is 45 degrees away from 180, well, if I go from 0 all the way around to here, that would be 180 degrees plus 45. And 180 plus 45 is going to give me 225 degrees. From here all the way around to here is 45 plus 45 is 90, plus 45 is 135, plus 45 is 180, plus 45 is 225, if you think about it that way. So I want to find the coordinates for D. Well, if we follow along the pattern, if I have an angle of 45, then this value is cosine of 45, sine of 45. If this angle is 135, this should be cosine of 145 and sine of 135. If I go all the way around here to 225, what should this coordinate be? Well, if you said the cosine of 225, that would be correct. And this value would be the sine of 225. Let me write it down here, 225. Well, maybe you can see it, but hopefully you can hear me. Now, how do these relate to 45? Well, the cosine of 45 is going to be, again, kind of like the same distance that we had away from x in the negative rotation. So the cosine of 45 is going to be equal to the negative of the cosine of 225. Or you can say that vice versa. The cosine of 225 is going to be the negative of cosine of 45. We'll address that in class. And the sine of 225, well, this is in the opposite direction of 45 and sine of 135. So the sine of 45 is equal to the negative of the sine of 225. And if we follow the pattern, we're going to notice here for E, this is 45, 45, 45, 45, 45, 45. That's 270 up to here, plus another 45. Well, that's going to be 45 degrees for making a full 360. So if you say 360 minus 45, well, 360 minus 40 is 320, minus 5 is 315. $315 plus 45 should give you my whole 360. So what would this be? This would be the cosine of 315, and this would be the sine of 315. And how do they relate to 45? Well, if you take a look here, the x value is the same as 45. So the cosine of 315 is equal to the cosine of 45. Now the sine is the same thing, only same distance from here to B as it is from here to here, only in the negative direction. So the sine of 315 is equal to the negative of the sine of 45. Now, what does that mean? If I take my graphing calculator, just to show you, and I say the sine, let's check to see before I do that, we're in radians, let's change that to degrees. And I say the sine of 45 degrees, that's going to equal to 0.707. Now let's take the cosine of, the sine of 135. The sine of 135, 0.707. So you see, they are both the same distance from the x-axis. Now let's take the sine of 225. And as you notice, it's the same exact value, only negative, because the distance away from the x, this distance here, from here to here, is the same as here to here, only now we're going in the negative direction, because you know, in the coordinate plane, below the x-axis, we have negative. And it should be the same for 315. If I take the sine of 315, it should give you the same as sine of 225, which is the same. And the same goes for cosine. We'll do one, but we're not going to do them both. So if I do the cosine of 45, that's going to give me the negative of, or cosine of 35 is going to be the negative of this. The cosine of 135 should give me the same thing, only in the negative direction. So cosine is my x value. So this distance here is the same as distance here, only one's going in the negative direction, one's going in the positive direction. I hope that makes a little sense. There we go. Now, one of the most important things is knowing quickly what the sine, cosine, and tangent are for several different common angles. If you learn that, it'll be very easy for you. You could either memorize it or come up with a trick. I'm going to show you both. The sine of 0 is 0. The sine of 30 is 1/2. The sine of 45 degrees is square root of 2 over 2. The sine of 30 is square root of 3 over 2. And the sine of 90 degrees is 1. The cosine of 0 is 1. You'll see that it's the same thing in the opposite direction. The cosine of 30 degrees is square root of 3 over 2. The cosine of 45, well, 45, square is going to be the same thing, square root of 2 over 2. The cosine of 60 is 1/2, and obviously the cosine of 90 is going to be 0. So you see it's 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1, and it's the same thing going in the opposite direction. 1, square root of 3 over 2, square root of 2 over 2, 1/2, and 0. For the tangent is 0. For square root of 30, it is square root of 3 over 3. For 45, the tangent is 1. And for tangent of 60 is square root of 3. And for 90 degrees, it's undefined. There's a little trick that I use sometimes when I can't memorize it or come up with it quick. If I'm going to do this, I'm going to do the same chart. I'm going to erase my numbers. And we're going to redo it in a way that maybe you'll be able to help you better. I set them up all as fractions. I start with 0, 1, 2, 3, 4, and I put all these fractions over 2. Well, let's do the easy ones first. 0 over 2, well, any number divided by, or 0 divided by any number is 0. This stays at 1/2. 2 over 2, that's just 1. Kind of erase big. Over here, for square root of 60 degrees, I have to take the square root of this. Actually, I should have taken the square root of all of them, but I take the square root of 3 over 2. And over here, if I take the square root of 4, the square root of 4 is 2 over 2. Oops. I messed up over here. Let's start again. I start with 0, 1, 2, 3, 4, all of them over 2. And take the square root of all of them. The square root of 0 is 0. The square root of 0 is 0, divided by 2 is 0. The square root of 1 is 1, which 1 over 2, darn it. Over 2. This stays, I can't reduce the square root of 2, so that stays the square root of 2 over 2. This doesn't reduce, square root of 3 can't reduce, so that stays a square root of 3 over 2. And square root of 4 becomes, well, the square root of 4 is 2 over 2, and 2 over 2 is equal to 1. And that's how you get your shortcut. If I write it backwards, I'm going to write 1, square root of 3 over 2, square root of 2 over 2, 1/2, and 0. To find the tangent, if you remember, from last year is sine over cosine. So if I divide 0 divided by 1, I get 0. If I get 1/2 divided by the square root of 3, 1/2, divided by square root of 3 over 2, this gives me 1 over square root of 3, which simplifies to square root of 3 over 3. So this is square root of 3 over 3. Square root of 2 over 2 divided by square root of 2, well, any number divided by itself is 1. For 60 degrees, if I take square root of 3 over 2 divided by 1/2, well, this reduces to the square root of 3, and 1 divided by 0 is undefined. So that's a shortcut method, or you can just memorize it, whichever way might be easier for you. All right. Now, whenever you're given an angle, there's going to be several angles that have the same degree measure as whatever angle you have. For instance, for the first one, if I have an angle that measures 35 degrees, this measures 35 degrees. In other words, my y value here is 35 degrees. What other angle is also going to have the same sign as 35 degrees? Well, there's going to be 3 other ones. Remember, we said the sign has to deal with my y value. So this angle over here, that has the same height as 35. So in other words, from 0 all the way to here, that's going to give me an angle with the same sign as 135. How do I figure it out? I say 180 minus 35, and I get 145. So the angle that has the same angle as the sine of 35 is the sine of 145. There's 2 more. Well, these are going in the positive direction. If I start at 0, and I'm going to go, and I'll draw it in green, in the opposite direction, starting at 0, but instead of going counterclockwise, I go clockwise, this will give me a negative angle. When I start at 0 and go clockwise, my angles will start at, 1 degree, 10 degrees, 15 degrees, 40 degrees, 60 degrees, but they're all going to be negative. So it'll be negative 10, negative 20, negative 45, negative 60, negative 90, and so forth. So to get from here all the way to here, that's going to be negative 180 plus 35. So the next angle that's coming up that is going to give you the same value as the sine of 35 and the sine of 145 is going to be 180 plus 35, which is going to be the sine of negative 215. That's going to give me the same value. And if I were to start here and work all the way around to this point here, I'm going to get 90, 180, 270, and we're going to be 35 degrees short of being a full 360. Well, 360 minus 30 is 330, minus 5 is 325. So this would be the sine of negative 325. All of these should give you the same value. If we plug it into our handy-dandy calculator, we're going to start with the sine of 35, and that's going to give me 0.57357. The sine of 145, same answer, 0.57357. The sine of negative 215, well, hopefully if I get it right, I should get the same thing, which I do. And then finally, the sine of negative 325. And you'll see that they'll all give me the exact same answer. All right, let's do the same thing for cosine. Let's say we start with a cosine of 35. This angle's 35. And I need to find an angle or three other angles with the same value as cosine of 35. Now remember, cosine deals with x. So my x values are going to be positive this way. So the angle I'm looking for is this one right here. They're both going to be the exact same distance away from my center. So if I start at 0 and I go to here, that's 35. Well, if I go from here all the way around in the positive direction, I should have made that green probably because, positive, green is positive. I'm going 90, 180, 270, and we're going 35 degrees just short of 360. So 360 minus 35 is 325. So this is going to be cosine of 325. So here's my location, and here's my angle. Those are my two angles, 35 and 325. What if I go in the negative direction? If I go starting at 0 and I go to here, then my next angle would be the cosine of negative 35. Because if I start 0 and I go to here, which is the same distance away from x, from the origin, that's going to give me a negative 35 degrees because I'm going clockwise in the negative direction. And similarly, if I go all the way around this way, I'm going to get the cosine of negative 325. The good thing I like about cosine is cosines, the angles will all be the same, just two positive and two negative. And just like I did with sine, I'm going to do the same with cosine. So cosine of 35 is going to give me 0.8191. Cosine of 325, 0.8191. The cosine of negative 35, 0.8191, and the cosine of negative 325, 0.8191. So they're all going to be the same. And the same for tangent. Tangent of 35, where is tangent going to be the same? Well, as you know, tangent is sine over cosine. So if this is 35, the other place where it's going to be is directly 180 degrees opposite from here, which will be, well, I guess I drew it. I didn't draw it as accurately as I wanted to. Here, 180 degrees away. So this will be 35. So at this point and this point, going in the positive direction, I'm going to be at 35, and then 180 plus 35, which will be to here. Well, 180 plus 35 is 215. And then going in the opposite direction, in the negative direction, from here to this same point, it's going to be 180 minus 35, which will be 145, or negative 145. And from here all the way to here, it'll be 360 minus 35, which will be 325. So negative 325. So what are the angles that are going to give me the same as tangent of 35? Well, it's going to be the tangent of 215, the tangent of negative 145, and the tangent of negative 325. Now let's see if this is correct. Let's try it on the calculator. The tangent of 35 equals 0.7002. The tangent of 215, 0.7002. The tangent of negative 145, 0.7002. And lastly, the tangent of negative 325, 0.7002. So you'll see they are all related that way. Okay? Hopefully in class I'll give you a shortcut that might make it a little easier for you to understand. And lastly, given that the sine of 50 is 0.766 to 3 sig figs, they want to find the value of cosine of 50. Wow. If I have the sine of 45, well, I can figure out the cosine of 45, but in this way is going to be a little bit harder. What we have to remember is what we talked about last time. Sine squared plus cosine squared is equal to 1. So if I'm going to use this to figure out what the cosine is of 50, well, I know that sine of 50 is 0.76, so 0.766 squared plus cosine squared of x is equal to, well, I'm sorry, not x, plus the cosine squared of 50 is equal to 1. Well, let's do the math. The cosine squared of 50 is equal to 1 minus 0.766 squared. And if I do that on the graphing calculator, I'm going to get 1 minus 1 minus, boy, it doesn't want to let me draw here. Let's try it again. 0.766 squared is equal to 0.413244. 0.413244 is equal to the cosine squared of 50. Well, I don't want the cosine squared, I just want the cosine. So I take the square root, second square root of my answer, and I get the cosine of 50 degrees is 0.643 to 3 sig figs. Now, here's 50 degrees, 130 would be here, with 50 degrees here like this. So what can you tell me about the cosine of 130? Well, it's the same distance as 50 in the opposite direction. So the cosine of 130 is going to be the same as 50 except negative. So this is going to be negative 0.643. Okay? So now we want to find the sine of 230. Let's erase this. I have 180. 180 plus 50 is equal to 230. So from here, all the way around this way is going to be 230. Now, we know that the sine of 50 is 0.766. So the sine of 230 is going to be the exact same value as the sine of 50, only we're going in, this is in the positive direction, and this is going to be in the negative direction. So this is going to be negative 0.766. And the cosine of 50, which we just figured out a moment ago as 0.643, if I'm going in the opposite direction, in the negative 50 degrees, well, this is going to be the same x value. So it's going to be the same x value as the cosine of 50, which is 0.64. Okay, so this is it for this lesson of trig. Make sure that you bring all the notes that you took down and ask any questions for tomorrow in class, and we will answer them together. Hopefully you liked this, hopefully you understood, and we'll put another one up in a couple of days.